So in this video we want to look at what voltage is and try and get a better understanding. A lot of people understand it very simply to be the push in the circuit which drives the flow of charge. So you might have a 12 volt supply, and so we think about the supply in terms of how hard it can push. If it's a higher voltage supply, it pushes more current around the circuit. And through our resistor in the center here, that's going to restrict the flow of current. So you've got the resistor opposing current, and you've got the voltage supply providing the push. We want to get into a little bit more detail than that. We can think of a supply as the pressure, the push, I guess, still, but in a slightly different way. How I think we should think about it is we've got this electrical pressure, but instead of pressure it's potential energy. Potential energy and electrical potential energy. So if you take the charges, positive charge coming out from the positive side of the battery, they start off with a certain amount of, we'll just say 12 joules of energy per positive charge, so 12 joules of energy per charge, and that charge passes around. As it hits the resistor, it goes from 12 down to 0 joules of energy, and then it goes back. If you had multiple resistors, it would divide up. So if you had 2 resistors in the circuit, let's demonstrate that with another colour. If we had the second resistor and they were the same size, it would go 12 to 6, and then from 6 to nothing. So your energy is used up or converted to heat in the case of a resistor, or light in the case of a lamp. The energy that is being carried by the charges is being used to do something, to pass through the resistor. As it passes through the resistor, it generates heat. And voltage is measured by comparing the energy at one point to the energy at another point. So in the green circuit, we've got 2 resistors. There would be 6 volts because there are 6 bits of energy per charge that is lost as it passes through there. Okay, now so that gets into what it is. It's the push, it's the energy difference between 2 points. You might I've heard it called the potential difference. The potential difference is the voltage, and the formula can kind of get into that. There's actually a number of different formulas. We're just going to focus on 1 or 2 here. The voltage is the energy per charge, and sometimes it's the energy difference between 2 points, like I was saying. So in this case, if you're told that there are 6 joules of energy lost from one point to another, and you've got 1 coulomb of charge, that would be 6 volts. Okay, so that formula there, V equals E over Q, gets into the guts of what it's all about. So there's other formulas as well relating voltage. You've got voltage is current times resistance. That's Ohm's law. That's a very useful formula. You've got, remember, with the electric field strength, okay, not energy, it's got the wiggly line underneath. Electric field strength is the voltage per meter between 2 plates, parallel metal plates, if they're providing the electric field. So that links them. You could rearrange that to make voltage equals electric field strength times by distance. But this V equals E over Q, that's our main one that we want to focus on. And then the last thing we want to do in this video is compare to gravitation, because that helps us understand some things really nicely. Now, instead of having our circuit here in this form, we're going to write it in this form here. Plus 12 volts at the top, and at the bottom is going to be our 0 volt, or our negative, if you like. Positive at the top, negative at the bottom. And we've got our we'll just stick with our 1 resistor through there. This is the way engineers draw electrical circuits, and it illustrates the point a little bit better. In comparison to gravity and gravitational potential energy, if you have a brick and you drop a brick down, it loses gravitational potential energy. So you might talk about it having 12 joules of energy at the top of gravitational potential energy and 0 joules of gravitational potential energy at the bottom. In our circuit we've got 12 joules per charge of electric potential energy, and then at the bottom we've got 0. So they're very, very similar, and having the circuit drawn out in the vertical way like we have rather than in a circuit like a closed loop over here, we can see from the vertical one that it obeys a kind of a gravitational thing, where the gravitational pressure is downwards in this case, the electrical pressure is also downwards. Yeah, that's a nice way to look at it. And one final thing is that this is a different colour, green. One final thing is you don't, just because there's a 12 volt drop, so if we go, just consider a single resistor, if we have a 12 volt drop across that, between there and there, that doesn't mean that we're going from 12 to 0. We could be going from 14 to 2, we're going from 17 to 5 joules per coulomb of energy, because what's important is that difference between the 2 points. So it is the change in energy. So that's why you might see the formula written with a change on it, change in energy per charge. I think we didn't talk about units, but that means you can have joules per coulomb as the units, you can have volts as the units, and if you wanted to rearrange our electric field strength times meters, it would be electric field strength times meters units, from distance units. So that's voltage, but it's probably helpful to keep thinking of it as the push in the circuit. When it comes to analysing in detail, stick with what you know is this stuff. A battery provides the electric field, which is the pressure, and that drives the flow of charge.